That's actually a really good question. I'm going to explain something that's seemingly unrelated, but at the end, you'll see how it answers Midnight's question. Let's get started. Last time, we stopped here. A Gen 0 GC happens and promotes the survivors to Gen 1. How does this actually happen? I'll skip the mark phase since most of you already knew what it does. At the end of mark, we know exactly which objects are live. I've marked them with check marks. Then the plan phase happens. The job of this phase is to produce info to decide if we should perform a compacting or sweeping GC. So we simulate the compaction in the plan phase. In other words, calculate the relocate address of objects if we were to compact. Now comes the interesting part. This calculation happens on what we call plugs instead of individual objects. As the plan phase goes through the Gen 0 part of the heap linearly, it makes each group of adjacent live objects into plugs. So objects 3 and 4 form a plug, and 6 and 7 form another. When we calculate the relocate address, we look for space for a plug instead of an object, which is much more efficient because we have much fewer calculations to do. In our simplified example, each plug only has 2 objects. In reality, there are usually many more objects in a plug. With this knowledge, let's think about Midnight's question. If we didn't have a free object as generation starts, when we do a Gen 1 GC, we could have adjacent live objects that span Gen 0 and Gen 1, which means a plug would be formed that spans both generations. If we want to indicate the first part of this plug as part of Gen 2 and the second part as Gen 1, it would require keeping more information about plugs. If we use a free object, which is never marked, it guarantees that they belong to separate plugs. We simply allocate a free object as a new Gen 1 start in between. I hope that was interesting to you. Clearly it was for Midnight.